So we've been talking about computing the derivative of a function, and we've talked about it in terms of computing the slope of a function at a certain x value, or computing the velocity or instantaneous velocity of an object moving. But we'd like to be able to generalize this a little bit. Instead of just computing the derivative or the slope at a specific number, what we'd like to do is come up with a whole new function. Because if we can come up with a function as a derivative, then all we have to do is plug in various x values. So instead of recomputing the limit to give us the slope at every point of a function, we can just compute the limit once as a general statement, and then use that to give us the slope of a function at any point by just plugging in that point. So how do we do that? Well, let's say we have a function f of x, okay? Then the derivative the derivative of f of x, right? So here this is just some function. There are some things that have to be true about it, like it has to be continuous and so on. But we'll talk about that later. Right, so the derivative of f of x is, we write this as f prime of x. Okay? And this is the limit as h goes to 0 of f of x plus h minus f of x over h. Okay? So here, notice we still have the variable x. We're not actually plugging in a number anymore. So your final answer here should still have x's at the end. All right? We could also use the other definition that we had for instantaneous rate of change. And here we'll want to do something like limit as t approaches x of, the order doesn't matter here. So if we do like f of t minus f of x over t minus x, that'll be fine. Or you can do it in the other order too, f of x minus f of t over x minus t. Either one of these work. This one tends to be the easier one to understand because we're taking the limit as h actually approaches a number rather than t approaching another variable x. But for some certain functions, this winds up being the easier one to work with. But typically, this is probably going to be your first choice. The f of x plus h minus f of x over h. Okay? So let's just see this in a quick example. Say, let's do the square root function. Okay? So let's say the function g of x is square root of x. Let's find g prime of x. Right? Just to see an example of this worked out. So, g prime of x, this is going to be the limit as h approaches 0 of square root of x plus h. Alright, because here we're just plugging x plus h into g. Right, so we're just computing this term here. Minus g of x, so minus square root of x, all over h. Alright? Remember, this here is where we want to use the conjugate, because we have these square roots on top. So multiply by the conjugate. Right? So square root of x plus h plus square root of x. Alright? Remember, we have to multiply the top and bottom. Okay? So this simplifies to, let's see, x plus h minus x over h times square root of x plus h plus square root of x. Okay? So we'll simplify this completely. Right? Again, I'll leave checking the simplification to you. All right, so it puts us here, and we get 1 over 2 square root of x. All right, so this is the derivative of g of x. All right. Oops. Let's do 1 over 2 square root of x. Okay, so again, what this is going to do now is, if we ask, okay, what's the slope of the tangent line at x equals 1? Just plug in x equals 1. What's the slope of the tangent line at x equals 9? And just plug in 9. Right? And any number we want, we can just plug it right into the derivative. Obviously, we're going to have many more uses of this function as we go on, and many applications of it. And we'll learn some tricks for computing this, so we don't have to do the limit every time. But it's important to understand the limit definition, why it's being defined the way it is, and how we use it. Okay? See you in the next one.